Good morning, ladies and gentlemen. Do this in your notebook now.
Good way to start the day.
Okay. Do you have something that looks similar to this? I'm not done yet. I've got my magnitude, my answer from the calculator. I found my direction, my angle. I found my angle.
The internal angle.
Yeah, but now I gotta resolve it to make sure it makes sense. So I started here, and it says that I walked 20 meters.
That's A is 20 meters
Oh,
north.
sorry, 20 meters north here, and then this direction is west. So if I make this into north, east, south, west, into one of these little compass rose, then I know that, well, if this is 21.8 degrees right here, I have to do some addition here. Now, all the way to right here, this is 270, right?
Yep. West is 270 degrees.
So I need to do 270 plus that 21.8, right?
Uh-huh.
When I do that, I get, what is that, 290.
291.8.
1.8 degrees. So my answer is 53.9 meters at 291.8 degrees.
Boom!
Boom. Sweet. It's not finished till you have that direction. Okay,
Don't do that.
don't do that. Moving on. Miss Moore walks 40 steps from C to A in the quad. Remember that quad thing we did?
I remember that.
It's a long video, right?
It's a nice cool day that day.
Yeah, it was. It's getting hotter right now. Next week is going to get cooler, though. I'm excited.
We have no idea when you'll be watching this.
So I walk 40 steps from C to A, and that's north.
40 steps north.
North is up. Okay, so we're gonna go 40 steps this way. North. And then from C to A, so this is C and this is A. She, not ye, turns and walks 20 steps to the east, which is this way. And that's letter L. And wants to know what is her net displacement. So we're trying to figure out.
The dotted line resultant.
Okay, we can do this, right?
It's just like the do now, just different numbers.
Okay, so my A squared, does it matter which one is A?
Doesn't matter.
No.
No, ma'am.
I'm just gonna use this one because it's right there. And I get square root of 40 squared plus 20 squared equals, and I get 44.7. I'm gonna call it 45.
All right.
Okay, 45 steps.
Yep.
And then what direction?
It's a vector. It's got to have direction.
Figure it out. So tangent -1. This is my angle right here because I'm starting here. It's my angle of the opposite over the adjacent. So tangent -1 of 20 divided by 40, and I get 26.6 degrees.
26.6 degrees.
26.6 degrees. Let's check my reference real quick.
Should be somewhere between north and east.
If this is north and that's east, I don't have to do anything, huh?
How many degrees is north?
0.
0.
Yeah, so it's just right there, right?
So it's 26 degrees more than 0, which is
Just 26.6 degrees. So my answer right here would be, instead of a question mark, 45 steps at 26.6 degrees. Sweet. Moving right along.
Could we work backwards?
Huh. Miss Moore walks 45 steps from C to L. How far north did I go? How far east did I go? Let me just erase these.
I was going to say. So if all we have is a hypotenuse, how can we find the adjacent side and the opposite side?
I'm gonna go ahead and put 26.6 right here. How do I do this?
How far north? North would be what part of the triangle? Which one would that be?
North is gonna gonna be this part.
Yeah.
And then east is gonna be this part.
Which one do you want to do first?
Let's do this one first.
What part of the triangle is that?
This is the adjacent side.
SOHCAHTOA, which one?
So if this is adjacent, this is the opposite.
Yeah.
So cosine is the adjacent, right?
Yes, it is.
The cosine theta equals opposite. Wait, sorry, that's not it. Adjacent. I just said the answer too. Adjacent over hypotenuse. Right?
Yes.
Okay, well we have the angle. What are we trying to find? We're trying to find the adjacent, so can I just go hypotenuse,
Multiply both sides times the hypotenuse.
cancel that out, put it over here.
Yep.
Hypotenuse times the cosine of my theta is going to give me the adjacent.
Yep.
You need to write this down. This is important.
Well, they've been writing everything
Yeah.
down as you do it,
And
Ms.
if you
Laura.
haven't, go back and
What's
do
up?
it again.
What's up with you?
Okay, let's go to write this in. So I'm going to go ahead. My hypotenuse is 45 steps. I'm not going to write steps, but just 45. Times the cosine of my angle, which is 26.6. And this will give me my answer. So 45 cosine, 26.6. And I get, I'm going to call it 40.2.
Sure.
Okay.
Well, you can't walk 40.2. You can't walk
Right.
off 2/10 of a step.
We'll go 40 steps.
40 steps.
Oh, that sounds familiar.
That sounds
So
familiar to
this
me.
is 40 steps. And we know the direction is
North.
north.
What's left?
How far east? So east is this side of the triangle. So, okay, now let's think about, we already did cosine.
What part of the triangle is east?
It's gonna be the opposite
Opposite side. Oh, that's, you've got it written right up there. Sorry.
Theta equals, opposite side over hypotenuse. We can do the same thing, right?
Yep.
Multiply by the hypotenuse. These cancel. Hypotenuse times the sine of the angle is going to give me that opposite side. Let's do it. Oh, my hypotenuse is again 45 times the sine of 20.6.6. And I get 20.
20 steps.
20 steps, and we know we're going east here.
We can work backwards.
We can. It's a beautiful thing. It is a beautiful thing. And oh, that was the answer.
So, forgot about this.
Do we need? Oh, I guess we don't need this, huh? Moving right
Nah.
along.
Yeah,
Okay.
you did it. Just blast through.
Okay. All right. Notes. Any resultant vector can be resolved into two perpendicular components. Exhibit A. If we know the length and direction of the vector arrow. So if we know the length and direction of this resultant, the length,
We did.
direction,
Yeah.
then we can resolve it, or what that means is just break it up into its components. It's this component and that component.
And they're perpendicular to each other.
Yeah. We could break it down. Vector resolution. Any vector can be resolved into two perpendicular components.
So that's what this is called.
Yeah, we call it vector resolution. So when I say resolve the vector, this is what I'm asking for. The components can be north and south, east and west, like we saw here, right? North, and then this one was east. Oh, whoops. Oh yeah, east right there.
Yeah, this is called the reference directions.
Yeah, and so you have to make sure you include the direction. When we say to include your reference direction, it means what direction, what is our reference frame here? What's
Right.
going on,
Yeah.
right? Or sometimes it might be the x and the y-axis, the vertical and horizontal.
Yep.
Okay. These are the steps for how to do it. This is what we just did. We sketched the vector, showing the angle to the reference directions, right here. Okay, showing the angle to the
Yeah.
reference direction, this being north, that being east. And then we use the cosine to find the adjacent side,
Right there.
to find the adjacent side. And then we use the sine to find the opposite side. The sine to find the opposite. And it's going to be the same every single time.
That's really not very complicated.
No. It's you just got to practice.
Speaking of which, let's
do
practice.
some. Okay, vector resolution. That's what we call it, right? A crow flies 2.35 miles at that many degrees from the fairgrounds to Merced High School. How far north is that? How far?
Well, you know them crows is looking for some trash to eat. There a lot of trash at Merced High School.
Okay.
Who said that?
You will remain nameless. All right, let's draw this. Okay, so it's crows flying, and it says it flies 2.35
Miles.
miles. Yeah, we're gonna go like this.
There you go.
Yeah. In fact, one thing. Well, I'll just go like this. So we've got 2.35 miles, and it is at.
The direction is 26 degrees.
26 degrees, right there. Okay. No, it doesn't matter which way you draw it. It's fine. How far north is that? How far east is that? So, okay, north is this way.
By the way, boys and girls, you go ahead and do this on your own. Pause this while we work on it.
Add an arrow here,
All right.
and then
That's the north one.
over here.
That's the east one.
North, east like that?
Yep.
Okay.
That's all good.
Northeast. Okay.
So
Okay,
the-
so let's resolve it.
Yep.
What were my steps again? Are they on the next slide, or should we go back? I know, go back.
Here it is.
Sketch the vector showing the angle to the reference directions. We
You've
did
done that.
Now we have to use the cosine.
Ah.
And okay. So I'm going to use the equation hypotenuse times the cosine of theta to get the adjacent side. Which one's the adjacent one?
I know. It's the one that's touching the angle.
Yeah, this is the angle. And this one must be the opposite then.
Yep.
Okay, so in order to find the adjacent side, I do the hypotenuse times the cosine of theta. And then to find the opposite side, I'm going to do the hypotenuse times the sine of theta every single time.
Yep. Now all you gotta do is put the numbers in, boom, 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 and then pick up a calculator.
Do it. 2.35
That's
times
a hypotenuse.
the cosine of 26. Equals, hypotenuse goes here. Okay, let's do this. 2.35 times the cosine of 26. And I get 2.1. We're talking about steps here?
2.1 miles.
2.1 miles, okay. I was like, what are we talking about again? 2.1 miles there. And then let's do this one up here. So the hypotenuse is again 2.35 times the sine of 26. That's going to give my answer. 2.35 times the sine of 26, and I get 1.03.
0.03. Now all you gotta do is label your vectors.
Yeah, let's label them. So this guy right here is 2.1 miles, and we're going north.
Yep.
And this one is, we'll call it 1.03 miles, and we are going east here. Sweet.
Sketch, cosine, sine, boom, done.
Done. One more problem.
After this.
Oh, after this. The helicopter one, yes. Give it a shot. Do it.
Now, boys and girls, as you read this and start planning it, are we north, south, and east and west here? I don't see north, south, east, or west. Instead, we have
Just degrees?
horizontal and vertical.
Oh, okay. A helicopter flies at 95 kilometers per hour. Oh, fast. As it rises at an angle of 35 degrees to the ground. What are the vertical and horizontal components? Oh, this is what you're talking about with the reference direction.
That's right.
Okay, components of its velocity. So let's go ahead and draw this. So the helicopter is rising, and as it's rising, it's going 95 kilometers per hour at an angle of 35 degrees to the ground. And this is my ground.
Yep.
Ground.
Put an arrowhead on that 95 kilometers. But there you go.
There. And so then, what are the vertical? Vertical being, let me make this a little longer. What are the vertical and horizontal components of its velocity?
I can't remember what the vertical is, but I know that horizontal is the one that does the horizon.
That's exactly how I have to remember it.
Vertical must be that other one.
So, okay, so this is the adjacent, and this is the opposite side.
We've got our sketch. We got everything there. How do we find the adjacent side? We had to use
We do the adjacent one is the cosine.
cosine
right?
function. That's right.
Hypotenuse times the cosine of theta, which means this one must be the hypotenuse times the sine of theta.
Yep.
Okay, let's do it.
Oh, we gotta put the numbers in. That's my bad.
Hypotenuse is 95 times the cosine of 35, and this one's gonna be 95 times the sine of 35.
This stuff doesn't look hard to me.
No, it seems to follow a pattern, right? Okay, no answer. Okay, 95 times the cosine of 35, and I get 77.8.
That makes sense.
Yeah.
So that means a shadow on the ground is going at 77.8 kilometers per hour.
Now notice the units can be kilometers per hour, meters, steps, it doesn't matter, right? These work for any of it.
Vectors are vectors are vectors.
Yeah, 95 times the sine of 35, and I get 54.5, I'm gonna call it.
Okay.
54.5 kilometers per hour.
Sweet.
So the x component, or the horizontal component, is going this fast, and the vertical component is going that fast. And if you were to add those two together, we'd get 95. Well, with our vector addition stuff. Okay, that's what we did.
So here's this simple 3 steps. Sketch the vectors showing the angle, reference direction. Use the cosine to find the adjacent side, and use the sine to find the opposite side.
Yeah, it's all there.
All they need to do now is practice it.
Okay, so we're gonna do this one for homework. Oh wait, yep, and then this one for homework. That one for homework. That's 3 of them. I think that's enough. 3, 4?
Sure.
Let's do 4. We'll stop here.
Okay?
Okay? Good luck, ladies and gentlemen.